Example 4. When 4.4 grams of ammonium nitrate is decomposed in a closed container, it will produce nitrogen, oxygen, and water vapor, and release a lot of heat. The temperature can be higher than 300 degrees Celsius. If the total pressure in the container is 86.2 atm, what is the partial pressure of nitrogen? When we are given a calculation problem, the first step is always to summarize the most important information. The most important information includes numbers with units, what we are looking for, and balanced chemical equations if there are chemical reactions in the problem. When you are looking at my summary, you will notice a special term called total gas. The reason I put on this special term because we know the total pressure of all gases together. Therefore, I need to put on a special term called the total gas. Then you may wonder, how do we get the total moles of gas from the balanced chemical equation? Remember, for a balanced chemical equation, it tells you the moles ratios between the reactants and the products. To get the total moles of all gases together, we just need to add the coefficients together, which should be 3.5 moles. The second step is to analyze. We want to find the path from what we are given to what we are looking for. From our summary, this looks like a stoichiometry type of calculation. Where should we start? Nobody knows until we try. Let's start from ammonium nitrate first. If we know the mass of ammonium nitrate, we can convert it to the moles of ammonium nitrate. Then, from the balanced chemical equation, we can find the moles of the nitrogen gas. Since we do not know the volume, the temperature of the nitrogen gas, we have no way to calculate the pressure of the nitrogen gas from the moles of the nitrogen gas. Well, you may wonder, can we use 300 degrees Celsius? But still, even if we assume the temperature is 300 degrees Celsius, we still don't know the volume of the gas. Therefore, we have no way to convert the moles of the nitrogen gas into the pressure of the gas. Well, if this doesn't work, let's try to use the total pressure. As we know, the gas mixture contains 3 different gases. Remember, there's a law called Dalton's law of partial pressure to handle the mixture of gases. Let me put down the equation from the Dalton's law of partial pressure. Well, this equation tells us that the ratio between the partial pressure of any gas over the total pressure is equal to the ratio between the moles of that gas over the total number of moles of all gases together. Since we are looking for the partial pressure of the nitrogen gas in the mixture, let's replace Pi with P nitrogen. Replace Ni with N nitrogen. We can get this ratio from the balanced chemical equation. The ratio should be 1 over 3.5. Well, since we know the total pressure of the gas mixture, we should be able to calculate the partial pressure of the nitrogen gas in the mixture. Then we need to show the work. Well, it seems the work is very simple. From our calculation, we can also learn another lesson. Not all numbers is useful when we calculate the answer for the problem.